Welcome to our channel. In this video, we are going to discuss about carbylamine reaction, and in our channel, we are providing handwritten notes for every topic which we have explained. If any one of you need to download handwritten notes for this topic, you just go and check out the description or else comment section where I gave the link to download PDF for this topic notes. So let's move on to the topic. Carbylamine reaction. So this reaction is also called as isocyanide reaction and which is used to detect primary amines. Primary amines in the sense we can consider both aliphatic and aromatic primary amines. Okay. Let's see the definition of carbylamine reaction. When primary amine, that is aliphatic or aromatic primary amine, is heated with chloroform and alcoholic potassium hydroxide, then it forms isocyanide or carbylamine. Isocyanide is also called as carbylamine. Okay. So let's see an example. Ethylamine. So it is a aliphatic primary amine. When this ethylamine is heated with chloroform and alcoholic potassium hydroxide, then it forms ethyl isocyanide. So isocyanide is also called as carbylamine. So it is very simple reaction, right? So let's take another example for aromatic primary amines. So I'll take aniline. We know that aniline is a aromatic primary amine, right? When this aniline is heating with chloroform and potassium hydroxide, then it produces phenyl isocyanide. So here isocyanide is nothing but carbylamine. So let us see the mechanism of this reaction. So actually in the beginning of this reaction, potassium hydroxide is break up into potassium and hydroxide. Okay, K plus and OH minus. And now you can see the chloroform. So it will be written like this, CH and Cl3. So you can see hydrogen gives its electron to the carbon. So that carbon gets negative charge and the positively charged hydrogen atom attracted by OH minus. And now OH minus abstracts this proton and coming out as a water molecule. So now you are getting C minus Cl3. Okay. Now again I will remove one more chloride ion. Then you will get 2 electrons with 2 chloride ions. So we can say that carbon valency is 4, right? So around carbon you can observe 2 bonds and 2 electrons. So valency is satisfied in the carbene form. So what I'll do now? Now I will take ethylamine. This ethylamine act as a nucleophile and carbene act as a electrophile. So now in this ethylamine, the nitrogen which is having lone pair of electrons, this nitrogen attacks on the carbon atom of carbene and forms a bond here. So we can see C2H5NH2 and the bond you can see CCl2. So now nitrogen is forming 4 bonds. As nitrogen is donating electrons, it gets positive charge. So carbon is forming 3 bonds. So actually carbon can form 4 bonds because of its valency. So that is indicating with negative charge. So that means here negative charge is indicating that it can form one more extra bond. And the positive charge indicating that the extra bond is already formed by this nitrogen. So actually nitrogen can form only 3 bonds. Here it is forming one more extra bond. So that means one bond with C2H5 and 2 bonds with 2 hydrogen atoms and one more bond with carbon atom. So that it is indicating with positive charge. Now in order to nullify this positive charge, I will remove this proton. So now this proton coming out as a H plus and satisfies this positive charge. So this proton goes and attack on this negatively charged carbon. So you can see CH bond is formed. So now you can see nitrogen is having again a lone pair of electrons on it. So now what will I do? Again I will remove one more Cl minus. So when I am removing Cl minus again here, this nitrogen donates its electron to this carbon. So this positive charge and this lone pair of electrons and donation of electrons forms a double bond here. So you can clearly see here. So whenever chloride is leaving out, it gets positive charge and nitrogen gives electrons and form double bond. So Cl minus is coming out. So in next step, again I need to satisfy the positive charge of this nitrogen. So OH minus comes and attack on this proton and donates its electron to the nitrogen. So that now this positive charge is nullified again. Now again nitrogen is getting a pair of electrons. So now I'll remove one more Cl minus here. So when I'll removing one more Cl minus, what will happen? This carbon gets positive charge again and nitrogen donates electron and forms triple bond. So again you can see around the nitrogen there are 4 bonds. One extra bond is formed by the nitrogen. So we are getting the positive charge again. So now hydrogen again leaving out as a H plus, and here this OH minus comes and attack on this hydrogen atom and coming out as a H2O. Again this carbon gets negative charge that you can see here, C2H5 bonded nitrogen triple bond C minus. This can be represented like this. So this is called ethyl isocyanate and we can also call it as a carbylamine.